Okay, in this section we pick up with our unit circle. It's a circle whose center is the origin and the radius of 1. The equation of the circle I provided there is going to be x squared plus y squared equals 0. Remember, this is with the center as the origin. Okay, and recall we just finished with this one in the last video. So S is equal to R theta. And we can see the relationship with, and that circle is going to be pretty small. So if I was to make that image a little bit bigger, then going through here, this is going to be our S, which is our arc length, and this is T in this case. So we let theta be T. Then S is equal to T for a unit circle. That's what that means. So the central angle measure in radians is equal to the length of the intercepted arc. And from that idea is where we get our definitions of the trig functions in terms of the unit circle. Now, in another lesson, we're going to visit in terms of any circle. But this one we're going to precisely do a unit circle. In unit circle, remember the radius is a set 1, a known 1. Okay, so take a few minutes and I want you to write your definitions. And the reason these definitions are in terms of sine of t is because we defined it that way with the image on the last slide. But this is the same thing as sine of theta. A lot of times we see it as theta. So sine of theta is equal to y. Cosine of t in this case is equal to x. Y over x. You also might want to make the comment here that x cannot equal 0 because you can't have 0 in the denominator, and on this side y cannot equal 0, x cannot equal 0, and y, because you cannot have division by 0. Alright, the next thing we do is we're going to look at a point on a unit circle. They're going to give us a point P. So for this example, if I sketched a unit circle, and if this is the origin and it says go -1/2 up square root of 3 over 2, let's just say it's roughly there and it lands on the unit circle. Then we're going to describe the 6 trig functions in terms of its position there. So first of all, using the definition, so from above, sine of t, so sine of the angle t is going to be just the y value. Well, what is the y value in this ordered pair? Recall it says point is x comma y right there, so if we want to label it above it might help. So what is the y value? Square root of 3 over 2. Okay, so then let's do cosine of t. Cosine of t, by definition, is going to be the x value of our point. What's the x value of our given point? -1/2. Good. Now the only one we'll probably have to do some calculations with is the tangent, because tangent is the y value, which this is the y value, over the x value, which the x value is -1/2. Now it's a fraction divided by a fraction, so this one takes some simplifying. So let's do the algebra. Multiply by the reciprocal of that. So it's going to be -2 over 1 times -2 over 1, and then you would just cross cancel and simplify this. So the whole bottom's going to reduce. This reduces to just negative. Don't forget this negative right there, because it becomes a -1. Negative square root of 3 over 1, which is just negative square root of 3. Alright. Now, these are reciprocals. If you look, if this is y, the reciprocal of this one is 1 over y. X, the reciprocal is 1 over x. Y, the reciprocal of this. So sometimes it's okay to extend that over here as well. Some people like to do so in some cases if they know they're sure about their first calculations. So let's do that. So cosecant of t is, what's the reciprocal of this one if you use that method? Or you can use the definition 1 over y, and you will get the same thing. But what's the reciprocal of this? 2 over the square root of 3, right? But the only thing about that is we don't want to leave radicals, rationals in the bottom, so we want to rationalize the denominator, and this is something you do in algebra. Multiply both by the square root of 3, and then you're going to get 2 square root of 3. What happens when you have a square root times a square root? You cancel, then you just get 3. So anytime that you can rationalize, you want to do that. So let's do secant of t. What's the reciprocal of this one? Negative 2 over 1, which is just negative 2. That one's an easy one. Let me circle those, so box those off so we don't get them confused. Cotangent of t. What's the reciprocal of square root of 3? Negative square root of 3. Actually, don't forget that negative. Yeah, negative 1 over the square root of 3. Right. No, yeah, negative square root of 3 over 3. So if you're going to do, let's show the calculations for it. So negative 1 over the square root of 3. Right, and then multiply both by the square root of 3 to rationalize. There's a couple different ways to do this. Whatever's better for you, you can do that way. Square root of 3 times the square root of 3 is just 3. Okay, good. Okay, here's your special right triangles. And I'm going to give you a few minutes to copy this down so that you can have those. A lot of what we do is based off of these particular ones, and actually trigonometry itself means the measurement of triangles. So go ahead and take a few minutes to have these. This one's a 45-45, a 90 triangle, and this one's a 30-60-90. They're special triangles, and I'm sure you've probably seen these before. We're going to use these to help us derive our unit circle in just a minute. Okay, the next thing we're going to do is we're going to practice using the above information to help us fill out the other information on these. Let me go ahead and set this one up. So here's our first example. Okay, if I have a triangle and I say this is side, and go more precisely by the degree angle, so I'll say this is a 45-degree angle, I want you to give me the missing side. So this is what you're given, the one on the left, and I want you to fill out all the sides, the lengths of the sides of all the missing ones, using the information and these proportions up here. So our solution is, if this is a 45, and if I'm given that this is side 5, then what is this side? Because it's a 1-to-1 ratio, so multiply by 1 and you're going to get 5. So what does that make this side? Good, because you would multiply by the square root of 2. So this would be 5 square root of 2. So if you have, we had a suggestion that the answer was 5 square root of 2, and that's the case because if you take 10, you divide by the square root of 2. Let's just do that. Then let's rationalize. And that would give us 10 square root of 2 over 2, and then that can be simplified, so that's going to give us 5 square root of 2. This reduces, and then if this side is 5 square root of 2, this 10 was given, let me write that down, and then what's the other side going to be? If it's a 1-to-1, what's this side going to be? 5 square root of 2 as well. Good. Okay, your next task is that I want you to take, and don't judge by the actual size of these rectangles or the angles themselves, but go by the numbers. I want you to have a side of 1, and I want this to have a side of 1. Using the relationship given here, fill in the missing sides on both of these. Okay, so I've kind of sketched the previous page right next to it so it can help you see how to fill out the missing side. So I want this missing side and this missing side on the 30, 60, 90, and I want the other two missing sides on the 45. Okay, so let's just check. So 2 divided by 2 will get us that 1. So basically, we divide everything. 1 divided by 2 will give us 1/2. And then this side divided by 2 gets us square root of 3 divided by 2. Alright, let's work with the other one. So for this one, to get from the square root of 2 to 1, you divide this by the square root of 2. So whatever you do to this side, you do to all of the sides. So basically, we're going to divide everything in this triangle by the square root of 2, and that's going to call for some simplifying. Okay, good. So that's simplified to square root of 2 over 2, which means this side. And then if I know this side, I know for a 45-degree triangle that this side is the same as well. Now I want you to look at these highlighted portions, and where we're going next is that on a unit circle, if we looked at this side as our radius of 1 for a unit circle, radius of 1, we're going to be able to use these triangles to help us fill out our unit circle.